Oh, and I'm going to give you your ACs back as well. So before you leave today, you're going to have those. And I adjusted quite a few. Normally it actually went up, and and that's good. Okay, so we start to look at the relationships between when you apply a scale factor, right? That the area or the surface areas are actually affected by k squared. And I want you to do this for me if you can. The fact that, right, whenever you get, like, let's say a centimeter squared or a centimeter squared, that is going to tell you that your scale factor is also going to meet that exponent of 2. You can't just keep it at k, right? And so when you're dealing with areas, you automatically need to square that k, right? Determine the volume of each prism. So we're going to go volume of original is just length times width times height. So the volume of the original is 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. So we have 30 cubic feet on the original. This is on page 18. And the volume of the new is also length times width times height, but in this case it's 10 times 4 times 6. The volume of the new is, you can go 4 times 6, right? That's 24 times 10, that's 240 cubic feet. And so if we were to say, hey, the volume of the new divided by volume of the original, if we compared those two and we stacked them, okay, what is 240 divided by 30 on a Friday morning? That'd be 8, right? 8. But I want to write this in terms of k. What was my original k value? What was it? It was 2, okay? Right? And so what power do I need to raise this to get that 8? 3, right? All right. I'm trying to make a point, that's why I'm kind of slowing down here, right? And so I will tell you that if you ever have cubic units, immediately you should think, okay, this is definitely volumes we're talking about. I have that cube there on top of k. Okay. So we conclude this, that the scale factor cubed is what you would get if you take the volume of the new and you divide it by the volume of the original shape. Similarly, trying to see here if I, oh yeah, I gave you, did it look different yesterday, your notes? A little different? You didn't have this part in there, did you? You didn't, because this is my draft. This is my clean, the one I gave you yesterday. Would you be able to fit that in though? Can you fit that into the first section here? Let me take my clean copy and I will try to add that with you. This is what it looked like yesterday, right? So if you can somewhere in there fit in, because it's still the same, like a diagram. I'm going to try to just make a small surface area of diagram is this is divided by the surface area of the actual. It's still the same, just like before. The wording depends on the situation, right? The terms you're going to use depend on the situation you're in. If there's a picture of something, I go diagram actual. If you're making a copy, I go new original, right? But I don't mix them up, right? I don't go one, like I try to keep those terms consistent. And so, all right, so I'm gonna stick with this one because you already wrote down this part here. And so we can actually, right next to it, say k to the power of 3 is volume of diagram over volume of actual. And you might think, why don't you just stick with the one, Mr. Dirksen? Because when there were copies made, students didn't know what to do. So is the copy the diagram, or is it the actual? Like, what are we talking about, Mr. Dirksen? So that's when I came in and I said, you know what, let's have two versions of the exact same formula to help you out. That's it. That's the only reason I'm doing that. And I'm just going to make sure we have that highlighted. And then we know volume, I need to make sure K is cubed. Surface area, I need to make sure K is squared. Okay. And here's the kicker, guys. Very rarely will you be given all of the dimensions you need to find the surface area and volume. You're not going to be given that very often. You're actually just going to be given either the volumes or the surface areas. Just like that. Boom. So that's why you need these formulas to work with that information. Okay. So I'm going to really much stick to these from now on. And always keep in mind that at the very top, if you follow me all the way to the top here, this one has never gone anywhere. This is going to be new over original, right? That's the one you got, and the other one is K is diagram over actual. Hasn't gone anywhere. But you know what? I was lying to you a little bit back then. This actually stands for length of the new shape over length of the original, or radius and radius, diameter, diameter, height and height. Those were all one-dimensional lengths, right? There was no areas there. There were none of that was there. So now we're stepping it up a level where this part I call two-dimensional, 2D, and this here is 3D, right? Three-dimensional. Because, right, you've got cubic units, and for 2D, you've got squared units. That's how you know whether it's 2D or 3D that you're dealing with. So in a sense, we're going to continue with the exact same concept. It's just now we're going to work with areas as well, volumes as well. Okay. All right. Ready? 19. Let's go over to 19. I'm going to switch over to my clean copy. Otherwise, I'm going to mix it all up. Here we go. Scale factor to determine 2D and 3D values. Okay, so watch this. An ice cream shop is making a smaller cone for smaller children. Use the diagram to answer the following. Determine the scale factor used to create the smaller cone. Okay, so in this case, we have diameter, right? Diameter and diameter. If you hear the word replica, you're thinking copy, right? Copies. So original, and what are we going to put on top of this one? I will put new because I don't want to get mixed up here. Okay. So in this case, K is simply the replica, the new goes on top, and the original goes at the bottom. Inches, so perfect. They cancel out. We don't like decimals, so what are we going to do? Yeah, times it both by 100 because I've got 2 decimals in the numerator, so I'll do the same thing to both. So that's 177 over 250. And just to keep in mind, this is going to be greater than 1 or smaller than 1. Your answer, smaller than 1. So a reduction happened from the original, which is very easy to see. The diagram is right there. Okay, so let's just go ahead and go 177 divided by 250. That's 0.708 or 70.8%. I still always want you to remember that those. Can you reduce this one? Nope, you can't. Okay. Calculator is giving you the exact same answer when you try to reduce, so that's it.
Excuse the interruption, please. With Ms. Neal, please call into the office. Ms. Neal, please call in.
I will focus on this one. I like to keep my fraction if at all possible, unless I'm only given a decimal, right? Let's focus on that. Determine the amount of waffle dough required to make the original cone. Okay. And here's where I want you to waffle dough. What are you thinking on? Surface area or volume? Surface area, right? I hope you understand that because it's what you use to make that, not to fill it. So surface area was right there. Anyways, that's why you answered so nicely. But anyways, I appreciate you answering. So watch this, guys. I'm gonna say this. Okay, I know stuff about both of these, and I'm gonna focus in on surface areas of both of them. Okay. Surface area means that it's 2D, correct? You're following me on a Friday morning? 2D? And so I'm going to say I don't have enough information to find a surface area using a formula, correct? Like using the formula for surface area, but I do know this, that K squared is surface area of new divided by surface area of original, correct? That's what I just gave you. Emphasis on the K squared. Big emphasis. K is already given to us, right? I'm going to highlight K. I'm going to highlight that green and green up here so you know, hey, I already have that. Right? So you bring that down. You say 177 over 250. I need to square the whole thing. Remember that from IPR? When you square a fraction, you square both of the numbers. And which one do I have on the other side? Very important to get this right. I have the new, right? Because remember, let's do this. Let's make a little table here. This is new. All of this is new. And all of this is original. Right? I keep that separated. So I know this part here. So I'm going to go 10.15 squared inches goes here. And this is going to be unknown to me. And after this, once you plug it in right, it's just use your calculator. Okay? So watch what I'm going to do. I'm going to square both of them. 177 squared is 31,329, 250. Do you need to put the 1 that I always showed you to do? The 1? You don't, right? Because this is a fraction on the left side, right? So you just square both numbers. 62,500. And on the other side, you have this. What are the only units that appear here? Square inches. So your answer is going to be in square inches. Okay. I'm going to continue over here. That's why I left room. So to find x, I'm just going to cross multiply and then divide. Right? So it's 10.15 times 62,500 divided by 31. So yes, the numbers are going to get big. Okay. But that is not at all a reason to fear this, right? So I get 20.25, right? If I round it to 2 decimals. Does it make sense that the surface area is greater of the bigger cone? Yes, it does, right? I'm always double checking. So this is good. I got that figured out. Next, I'm going to use a different highlighter. That's why I told you have 4 highlighters minimum if you want to follow this, right? But I'm going to highlight my volumes. And that is going to be my 3D. It says determine the amount of ice cream the smaller cone can hold. And I tell you that this is volume, right? Right there. So I'm going to say that it's 3D because of volume. So what's my formula going to start as? It's going to be K cubed. There we go, guys. And so it's volume of new, volume of original. Mr. Dirksen, if I wanted to use, look up to K, 0.708, right? The decimal, could I do that? The answer is yes, you can, absolutely. And I almost feel like I want to do it just to show you. So should I keep it? I will keep it like this for now. Maybe a side, I'm gonna do it on the side if I have room. So I'm gonna cube my K, and K stays the same once you find it. What do I know in this case? The volume of the original, right? Right? Yeah. 2454 cubic inches. And this is, let's call this Y. And I'm going to use that orange highlighter, and wherever there's a power of 3, I'm going to kind of just emphasize that. And you know what else gives it away? You see inches cubed? That should also give it away. It's like, oh, my scale factor needs to have that power, right? If it had just been inches, then the exponent is technically 1. So K is just to the power of 1, which we ignore. We don't worry about that, right? So let's cube both of them. That's how, this is the hat button. I don't know if you remember the hat that gets you to the power. And this is a big number. And this just stays the same. Okay. And then I'm moving up. And so Y is, remember, you go to where the variable is. The number is down here, so you're going to have to multiply up, divide going down. And that's what actually makes applied, in my opinion, more fun, that we can throw any numbers at you and you can just work with it. It doesn't have to be a number that can be, you can find the cube root of easily in your head, right? We don't need to stick to that script. We just go, right? And I'm just going to copy my answers, right, from my calculator. times divide, and that's 9.06 cubic inches. Does it make sense that there's less volume in the smaller cone? It does. Check. So this is a classic where, first of all, you have to find a scale factor. And now I can ask you a whole bunch of things, right? And you basically fill in the chart. You fill in the chart here, right? Can I do that really quick here for you with you on the side, because you're gonna see charts later on. Let's get the original in here, and let's get the new in here. What did we have for both of them? The diameter, we had the surface area, and we had the volume. Right? We had both of their diameters. We had the 2.5 inches and we had 1.77 inches. We only had one of the surface areas, which was the new, which was 10.15. And then we were given the volume of the original, which was 2454. And this is X, and this is Y. We just filled in, we kind of completed this chart. And what did we start with? The only one we had both of to get us started were the diameters. Okay, and then we filled in the rest once we had our scale factor. So those formulas, like the K new over original, is key to almost anything we do in this unit, right? We did some converting, stuff like that. Just make sure that your units are the same. In this case, both of them were in inches, right? So if one is in feet and one is in inches, like, oh, wait a minute, I need to have them in the same units to cancel out, and then I can come up with my scale factor. So I just don't want to throw too much in the mix right now, because then you're gonna drop the course. No, you won't. You'll work hard and you will stay at it. You will persevere. Let's do the next one here. I know Coca-Cola is not sponsoring this lesson, so it's just an easy picture to find. Coca-Cola has made a new larger pop can. The original can is able to hold 355 milliliters and requires 322 square centimeters of aluminum to produce, while the larger is able to hold 500 milliliters. Okay. Determine the scale factor used to create the new can. And let me just, yes, okay. I got this. I had to think a little bit about it. You can have this on your study sheet, that 1 milliliter is the exact same thing as 1 centimeter cube. Okay. That is just a study sheet entry. So what can we say about the 355 milliliters? I can rewrite it as 355 centimeters cubed, correct? I hope you follow that. It's a bit small, I get it. Let me see here, I need to focus this one. You can do it. And I think yesterday I had grayscale. There we go, then it doesn't flicker. All right. Let's also rewrite the 500 mLs to 500 cubic centimeters. And let's get going here. I'm going to come over here a little bit because I don't move a whole lot. To find the scale factor, I need to have both of the same. So either both heights, both diameters, both areas, both volumes. It's the only way you can do it. What do you have both of in this case? Volumes, right? I have volume for this one, I have volume for that one. I don't know both heights. I don't know both surface areas. I only have this for both of them. Okay? So go ahead and highlight that because that's important to understand. That we're going to use these two here to identify that I know both of them. Then you can't see my highlighting. It's stressful. Life is very stressful for me when I print in yellow. I won't do that anymore. So what D are we in? 1D, 2D, or 3D? 3D. Okay. So we go over here and I look at my study sheet and say, which one am I going to use for this one? I'm going to use K to the power of volume of new, volume of original. It's okay to use new and original, correct? Which one is the original? The 355, yeah. And this is my new larger cat. So that is actually going to be most popular, new and original. So I'm going to say, okay, do I know my scale factor? I don't. Okay, so I'm going to keep it like that. I know both volumes, correct? Volume of the new is 500 centimeters cubed. Volume of the original is 355 cubed. What do I expect my scale factor to be, greater than 1 or smaller than 1? What happened to the original? Get enlarged. So K is going to be greater than 1. All right? So, do you remember what happens when K cubed? How do you get K on its own? Let's see if IPR teachers were good. What do you need to do? If it's K squared, what do you do to both sides to just get K? You square root, right? For K squared. K cubed, I need to cube root. There you go. Jalen was right on there. Ah, so this cancels out, right? So this is just for show. The left side is just for the show of it. Math really happens on the right side. And this is where you need to grab your calculator. Because there is no cube root on this calculator. Like, what were they thinking? Seriously, right? Like, it's so common. Why don't you just add that? But anyways, I will show you how to do that. I will first go 500 divided by 355. Go ahead. So this is cube root of 1.408. We are not going to round because we have this awesome calculator that will help us with that. So cube root is found the following way. Or did I show you already? I did? Math. Press math. The fourth option, so go arrow down to the fourth option or press number 4. It's up to you. Hit enter. And then you see the cube root there, right? Just waiting for you. I'm going to go up, copy my previous answer into it. Look, it even finishes that root, right? All the way to the end. And then hit enter. So that's 1.12, correct? 1.12. And what are we in? What units? Unitless, right? Remember, scale factor is unitless. There we go. Boom. So I'm just going to say you have to press math. This means button, right? Math 4 to call cube root. Okay, so if you want that in your notes, I don't know if you want to make like a cloud around it. Math 4 calls cube root. Okay, just like math 1 is for reducing a fraction, math 4, chances are if you're wondering where it is, use math. Use the math button. Unfortunately, it won't solve anything for you. Okay? You have to do the rest. Okay, now that we have scale factor, guys, this is like the key to success, right? Like once you've got the key, you can drive the car anywhere. Think of it that way. So the scale factor stays the same. It is greater than 1, which is what we expected. We could say this is 112%, right? If you wanted to put it in just for you here, okay? So it increased by 12%. From 100, it went to 112. All right, let's do the rest here. I want you to try this. I want you to try B and C using the formulas that so on page 20, the amount of aluminum required, I hope you understand that that is surface area. Surface area required, right? So you kind of have to translate things into what does it make, does it make sense? Yeah, surface area is the aluminum required. So we need surface area. So that's definitely 2D, right? So that means that I have to start with this. Okay. You don't always have to write it out like that, but I for notes, right, it's important. Oh, sorry. So here's where you're like, didn't you always tell us fractions, Mr. Dirks? Well, not always. Well, you have that, right? So you actually just use your answer, 1.12 squared, right? Surface area of the new is unknown to me. I do know the surface area, right? I know the surface area of the original, correct? So it's very important to place it in the right slot. If you get it wrong, right, then your answer will make sense. So X, watch this. You know the 1? This is where the 1 comes in. So you have a choice. You can go ahead and square 1.12, or you can just leave it to the power of 2. The calculator will take care of that. So I go this times this, right? So it's 322.57 times 1.12 squared divided by 1, which is, it's irrelevant, but you can write it down if you'd like. And so it's 322.57 times, I'll put that in brackets just to make sure nothing happens that I don't want to happen. And so that's 404.63, right, squared, 404.63. And if you got this wrong, not a big deal. Just learn and move on, okay? So that's how much is required there. So once you have your scale factor, you keep using it. Determine the height of the larger can. Height is 1D, right? Larger can is the new in this case. So they want the height of the larger. So I can just use this one. So it's basically height of new over height of original. So 1.12, no power. I mean, there's a power of 1, but other than that, nothing. Which one do I know? I know the original, and it's in centimeters. And so this is my unknown. I'm going to call that Y, you can call it H, whatever. And if you need this to help you out, right, to see the two fractions, right, Y is, in a sense, 12.2 times 1.12 divided by 1. Let me just move the camera down a little bit. There you go. So it's 12.2 times 1.12. And that's 13.66 centimeters. Got it? I hope you tried. I hope you didn't just wait there. It's like, give it a try. Big deal if you get it wrong. Stakes are so low, okay? Can I add? I want to add something here on the side. I just looked at the homework, and this will come up from time to time. Okay. Let me think a little bit about it so that it works out. Yeah, okay. If aluminum costs $25 per square meter, right? How much would it cost to make 2,000 cans? Trust me, it says cans there. Let me zoom into that area. If aluminum costs $25 per square meter, how much would it cost to make 2,000 cans? Okay, so I'm going to kind of try to keep it in here. So first order of business, oh sorry, which can are you talking about, Mr. Dirksen? Which one do you want to make, the new or the original? The new? Okay. New cans, that is. We're going to pretend like we're figuring out the cost to make the new cans. So we'll say this. Surface area that is required would be 2,000 cans times, what's the surface area of one new can here? 404.63. This is going to be a loaded question, as you can tell. So let's do that. 2,000 times 404.63. That is 809,260 what? Centimeters squared that I need, right? Aluminum to make these cans. What's that? You have to convert it to meters, exactly. That's what I meant by this is a loaded question. I'm trying to review what we've already done as well. So yes. So we're gonna go, I don't know if I gave you this one just like that, but I know that 1 meter has 100 centimeters, correct? But I can't use this one as is, can I? Introducing brackets, and I square the whole thing. So really it's all of this divided by 100 squared, which is 10,000. Right? But you don't need to memorize that. You can just use your, right? So I'm going to take that answer. I'm going to go divide it by 100 squared. So I need 80.926 squared meters. It's probably not going to be a realistic answer. I just made this up. But the cost, I mean, the cost, I have no idea what Coca-Cola pays for. But this is how much I need to make those. But guys, we cannot buy partial square meters. That's normally, if I tell you you cannot buy partial units, so how much are you going to need to buy? 81. Yes. So you're almost there. You had to figure out how much do I need in the first place. Oh, how much is this in square meters? And now is the cost. So you're going to go 81 times 25, correct? 25 bucks. 81 times 25, that's $2,025. It's about $1 a can. I don't think so. I think this is not realistic, right? There's no way it's that much. It's not $1 per can. That's probably what you get it at the vending machine, right? But so they probably pay a lot less. Anyways, it's just I just wanted you to have an example of converting, finding the cost, yada yada yada. Right? Okay. Next page. I feel like at this point you should be able to read and get going with that one. That is my goal. When I got to this point, I wanted you to be able to do that. So let's flip over to this page here. I want you to highlight important things. I want you to scan and see if you could do this right now on your own. So I will just ask you to do A and B, okay, for that kite question. So take it back here. All right, so we have Jasmine is making a kite using a model, right, made with a scale of 2 to 25. The fabric required to build a scale model is 20 centimeters squared. Calculate the amount of fabric needed to build the actual kite. I don't know about you, but if I see the actual there, right, what does it mean? The model is then the diagram, right? So there will be hints somewhere to help you out, okay? So would you agree with me that if this is the scale, right, then this is the scale factor? All right, yeah, we can agree on that. No units, so yes, right? It's just a straight answer. So what we do then is we're like, okay, what are we going to use? So this is a fact. I'm going to put that aside. I got my scale factor. So I'm going to see here, what am I trying to find? And it seems like we're dealing with squared units, right? Two-dimensional. So my formula should be k squared is equal to area of diagram, area of original. Don't mix it up, because that is bad, right? Area of diagram, area of actual. We're doing good so far. This gets plugged in there. Square that. The diagram, area of diagram is already there. That's 20 centimeters squared. And so this is my unknown here. I'm going to square both of them. So I get 4 over, is it 625? Yes? Yeah. Okay. Because I don't even have my key here, so I'm just going with it. So there we go. X is 20 times 625 divided by 4. And is it 3,125? Yeah. Perfect. And I'm in centimeters squared. However, it's asking me to also state this in squared inches. So we're going to just go ahead and say that, let me think. 1 inch has 2.54 centimeters, correct? I need to square that. So it's really 3,125 divided by 2.54 squared. And that's 484.38 squared inches. So this is an answer, and this is also my answer. Does that make sense? Friday, ouch, right? Ding, ding, ding. I agree. Jasmine made another kite using 500 square centimeters of fabric. Watch this, a little trickier. What scale factor would be required to make that model? So obviously, if you're making another one, there's a new scale factor. So I'm going to say, so what are we going to call this one? Another one. What are we going to call the other one? We can call that the new like, would you call that the actual, or what would you? Because we're using this model, right, to now make a different one. Got it? So I'm going to use k squared is equal to, because I don't know what the scale factor is. So what is the diagram? So I would have to go area of diagram, area of actual. This is the area of the diagram is still 20 centimeters squared. And the area of the actual that is being made here is 500 centimeters squared. What will I have to do here? Square root, because you're trying to find k on its own. I don't know if you were right, like it's an inverse operation, right? Like you're trying to get rid of that. So you're trying to find the scale factor by being given two areas. And so you grab your calculator and you can go 20 divided by 500 first, sorry, and then take the square root of that, right? So it's square root of 0.04. Second, x2, call 0.04, and it's 0.2. No units. Hold on. I know the bell's gonna ring real quick. Does this answer make sense? And you're like, well, isn't this an increase? No. What happened to the diagram? Or sorry, what happened from the actual to the diagram? Right? The 500 is the actual, diagram went smaller, so it makes sense to have a K. Hold on, homework. In your booklets, I will post the answer key 9 to 12 in the booklet. You're using what I taught you today over and over again. You just have to know what are they asking me for, what are they giving me, okay? Thank you guys. Have a good long weekend.